Hello everyone, a warm welcome to Sarat Chandra IAS Academy where your dreams are our mission. This is Yatharth here. In our today's UPSC view video, we'll be talking about a topic from geography, that is the Indian monsoon. We'll be seeing various things. First of all, why is it in news? What is the forecast for this year? And why is it so special? What are the factors affecting this forecast? What is the LPA? And we'll see what are the factors affecting the Indian monsoon this year, whether it is El Nino, whether it is Dalina, whether it is the Indian Ocean Dipole, and specifically we'll be talking about the southwest monsoon. So let's go about the lecture. First of all, we'll see why is it in news. All right, so India is likely to receive above normal, and this normal here is very special actually. We need to see what is normal, all right, and how much above normal we are going this year. So, which season we are talking about? During the June to September season. June to September season. This is the season of the southwest monsoon. Okay, in which the monsoon winds come from the Arabian Sea as well as the Bay of Bengal side. So, IMD has forecasted that we are going to receive above normal rainfall this year in the southwest monsoon season. All right, and this is after 8 years such forecast has occurred that we are going to receive above normal rainfall. All right, we need to also take care that during the April to June season, there is already a forecast of the heat waves. And this is because of this year being the El Nino year. Okay, 23 we saw it was the La Nina year. And we saw major flooding happening in the northeast region, especially. We saw floods in Pakistan. All right, and we saw floods in various different parts of our country as well. Okay, there were heavy rains. So, this is a forecast of this year. Now, let us see that what is the average and what is the forecast. So, first of all, the forecast is that we'll be receiving 106% of the LPA. Okay, now this LPA is basically long period average. Long period average. And we'll be receiving 106% of the long period average for this season. Which season? June to September season. June to September season. All right. So now let us see what is the LPA and what is the average. So the IMD categorizes the seasonal rainfall as above normal when it ranges between 105 to 110% of the LPA. Okay, if it exceeds even 110%, then we'll say that India is going to receive excess rainfall. Okay, you can see here normal, above normal, below normal, and so on. So 106 is falling between this, so above normal category. All right, and forecast probability is 31% here. All right, now let's talk about what is the LPA. Okay, what is this long period average and how long is this period? So this period is 1971 to 2020. All right, 50 years period. So the average rainfall that occurred for 50 years, okay, we are going to receive 106% of this LPA this year. So for June to September season, this rainfall is 87 centimeters or 870 mm of rainfall. So 106% of this, we are going to receive approximately 922 mm of rainfall this year. Okay. Now let us see why is it happening? What are the causes? So there are four main factors. Four main factors. So what are these factors? So now we are talking about the factors that are causing the above average rainfall, that are basically increasing the rainfall. So please note that all these causes are directly proportional to increasing rainfall. So what are the factors? Four main factors. First is the retreat of the El Nino. That means El Nino is going down. So El Nino going down is positive for Indian rainfall, first of all. Okay, favorable La Nina conditions. Favorable La Nina conditions. So increasing La Nina is good for rainfall in India. Second, positive Indian Ocean dipole. That means positive phase of the Indian Ocean dipole is favorable to rainfall in India. And reduced snow cover in northern hemisphere. Reduced snow cover. So because this is because of the we can say two things. One is the heat waves, and second is the climate change. Okay, so this will produce more rainfall in the northern hemisphere. Okay, so all these factors are very important for the Indian rainfall and favorable. What? El Ninos decreasing, La Nina increasing, and positive phase of the Indian Ocean dipole. Now, first of all, let us discuss and see a bit about the southwest monsoon. Okay, so we can see here there are two branches of the southwest monsoon. The Bay of Bengal branch, we can classify or say it is the second branch, and we'll say that Arabian branch is the first branch. All right. So Arabian branch is constituting 65% to this overall monsoon. So this is the major branch. All right. And it is constituting, the Bay of Bengal branch is constituting 35%. How much? 35%. So it is the secondary branch. Okay. So primary is which one? The Arabian Sea branch. And now you can see this is the rain shadow region. The levee side of the Western Ghat is the rain shadow region of the southwest monsoon. So when the monsoon comes back, the retreating monsoon, only then it rains in these regions. Alright, this is the retreating monsoon, which takes place in the winter season of India. So we are not talking about this, we are talking about the southwest incoming monsoon. So it doesn't rain here this time. Okay, but it can cross here through the mountains. It can go directly into Gujarat region and so on. And circulating the Aravallis, it will make rain in this region, especially in Rajasthan region. Okay, the Tapi River Valley, the Narmada River Valley, the Vindhyachal, the Satpura ranges, as well as the Aravallis. Okay, so this is the monsoon which makes rain happen in the western Rajasthan as well. Okay, now the Bay of Bengal branch, it goes inside in India from this northeastern plateau, and then it cannot go any further from here, so it circulates and comes to this side. Okay, the northern plains side, and when it strikes the mountain and multiple high places here, then it makes rain in this sort of region. Okay, so the rain keeps on decreasing as it keeps on going west, but high rain can occur in these areas, in the northeastern plateau area and the northeastern hill area. All right, you can see the Maneswaram here and the Cherrapunji here. So these are the most famous places of the rainfall. Maximum rainfall is recorded here because of this Bay of Bengal branch. And when this monsoon retreats, comes back, then it rains in these rain shadow regions of the Western Ghats. All right, so let us see some points about the southwest monsoon. So it's also called the rainy season of India from the June to September. And the southwest monsoon is caused by an intense low pressure system. Please remember this, forming over the Tibetan plateau. Okay, so the low pressure system is what attracts the monsoon first of all. Okay, as a result of intense heating during the summer season. And they bring a lot of moisture with them as they pass over the equatorial warm currents. Alright, the rain begins when these winds hit or strike the mountain barriers. And these southeast trade winds cross the equator and enter the Bay of Bengal and the Arabian Sea, only to become entangled in the air circulation over India because of the attraction by the Tibetan plateau. Okay, so we can see the reduced snow cover and high heat. The snow cover is reduced and high heat is there. Okay, so that is why the attraction from the Tibetan plateau. Just a second. Tibetan plateau is this side. Okay, so the attraction from the Tibetan plateau is very high. The low pressure system is very high here. That is why it's attracting the southwest monsoon. Alright, now let's talk about the first important factor, that is the El Nino. Okay, so let's talk about the El Nino. So what is El Nino? So during normal conditions, we are talking about the normal weather first of all. And where is it happening? In the Pacific Ocean. Please remember the Pacific Ocean. Alright, between the South America and the Southeast Asia or Australia we can talk about. So trade winds blow west along the equator. So these are the trade winds, they are blowing west. Now what they are doing is they are carrying the water with this also. Okay, so warm surface water is carried with these winds towards this side. Alright. So now what happens as this warm surface water goes towards the Southeast Asia or even the Australian side, the ascent of the cold deep water happens. This is known as the upwelling. What is this known as the upwelling? Now El Nino and La Nina are two opposite climate patterns that break these normal conditions. Okay, these are the normal conditions. Now there might be a break in these conditions. Okay, so what break happens? Either the El Nino takes place or the La Nina takes place. So simply we can say when this pattern, this movement, if you can just remember this is a clockwise pattern. Okay, when it becomes stronger, then it is La Nina. And when it becomes weaker, it is El Nino. Okay, so we have seen normal weather. So what we can expect in El Nino is that this upwelling will not happen first of all, and this warm water will not reach here. All right. So in normal weather, what happens when the warm water reaches here, then a low pressure zone is formed here, and the moisture goes upwards and it rains here. Okay, so this is wet, and this is also not specifically dry. Okay, now let's say make it weaker. Okay, so what happens that this trade winds, the flow of the trade winds toward the Southeast Asia stops or even reversed sometimes. All right, so this warm surface water does not go here, and instead it keeps coming back to this side. So first of all, the upwelling does not happen. Now because the upwelling is not happening, second thing is rain is not happening here. Okay, so this area becomes dry completely. And in the South America, what we see that the warm water is here up to 5 degrees Celsius. An increment in temperature is recorded in the sea levels. And the moisture comes here and it rains here. So there are floods in the Southern America. On the other hand, what we can expect in the La Nina, that this phenomena reverses completely. Alright, so let's see about this. Now what we can see here, this is the South America, sorry. This side down here, and it is majorly being affected from this extended Pacific jet stream. We can even see in the North American region that in the Pacific Ocean only, El Nino is also affecting the North American region. We can see here the warm, the dry, and the wet weather storms. All right, so this is a continuation to the. Furthermore, if we continue the map here, we'll see the Southern Americas here, down here. All right, so they correspond to the wet regions here. All right, during the phase of the El Nino. Here we can see. All right, now let's go to the other side, that is the La Nina side. So in the La Nina side, what we see here near the equator and the Southern Americas, that these trade winds even intensify. All right, these trade winds even intensify. So there is warm water, the flow of the warm water increases to this side, and upwelling increases this side. Okay, so they enjoy a good fishing season. Okay, because of the upwelling, there are good fishes. So they enjoy the good fishing season. However, this side, what happens near the Australia and the Southeast Asia, the flooding takes place. Okay, because over moisture is coming here. This side, the over warm water is coming here. So there is an increment in the rain events near the India, the Australia, and the Southeast Asia. So this is what happens in the La Nina phase. All right. Now let us also talk about the Indian Ocean dipole. So Indian Ocean dipole is basically the same thing or a similar thing. What we see in the Pacific Ocean, we see two things, the El Nino and La Nina. Okay. However, in the Indian Ocean, we see the same thing and we call it the Indian Ocean dipole. And we have divided it into two phases, the positive phase and the negative phase. And we just have to remember that the positive phase of the Indian Ocean dipoles helps it rain in India or increment in the rain in India. Now this is the neutral phase of the Indian Ocean dipole. So what we see here, that normally we saw the trade winds were coming from here and it was moisture here little bit. Okay, not a lot of moisture. So this moves towards anti-clockwise. Okay. So we saw that the El Nino La Nina phases, they were moving clockwise in the neutral phase. Okay, water was coming from this side and raining here and going back. Okay, so this was the clockwise. However, we saw that Indian Ocean dipole normally is anti-clockwise sort of situation. Okay, so in neutral phase, it is not supporting the rainfall in India. So IOD, it is also referred to as Indian Nino, is similar to El Nino phenomena, alright, occurring in the relatively smaller area in the Indian Ocean, between where the Indonesian and the Malaysian coastlines. This is the Indonesian coastline and the Malaysian coastline. Okay, and in the east and African coastline near Somalia and the west. So here is the Somalia and all. So this is taking place between this smaller area, which is Indian Ocean. So it is our local El Nino. Okay. So the El Nino is the warmer than normal phase of the El Nino phenomena, ENSO phenomena. So similar, we see two types of changes in the IOD, the positive phase and the negative phase. So let's see what happens in the positive and negative phase. All right, so this is the positive phase, which helps Indian rainfall in the India. So positive IOD helps the rainfall along the African coastline and also over the Indian subcontinent. So usually what we see that this was going anti-clockwise. Okay, now in positive phase, what happens? It starts going clockwise. Okay, so it is carrying more moisture and water from Australia towards the African side. So what it does, that it takes the warm water and warmer air towards the African side. So from the equator, the moisture was coming here towards the Australia. All right, and now the positive phase has started of the IOD. So it carries this moisture and the warmer air towards the African region. Okay, so making it rain more in Africa and India in the middle. All right, so what do we need for the good rainfall in India? We need a La Nina, we need a La Nina, and plus we need a IOD positive phase. Okay, that means good rainfall in India. Now, what happens if IOD is positive and there is El Nino? Okay, not so good. What happens if IOD is negative and there is El Nino? That means pretty bad. All right. So what we see, positive IOD rainfall helps along the African coastline and also over the Indian subcontinent while suppressing rainfall over Indonesia, Southeast Asia, and Australia. Now, what will happen if this is in negative phase? All right, it will flood in Australia. And here is the La Nina condition. Then it will flood in Australia. All right. So as I already explained, the impacts are negative or opposite during the negative IOD event. So pretty simple for us to remember. So let us see the negative phase of the Indian Ocean dipole. So what will happen in Indian Ocean dipole negative phase, that the rain that is coming from the Australia, okay, it will stay in Australia. It won't come towards the Indian side. So how will we manage that? That the trade winds or we'll make them flow towards here or stay here only. So it will flood in the Australia. Flood in the Australia. So how it will flood in the Australia? First there has to be a La Nina event plus negative phase of the IOD. Okay, so it is not a prime factor. It is just, let's say, affecting 10 to 20% of the Indian monsoon. All right, the main factors are the El Nino and La Nina. So at present, neutral IOD conditions are prevailing over the Indian Ocean, and the latest climate model forecast indicate that positive IOD conditions are likely to develop during the later part of the southwest monsoon season. So we can say that during the last part of the monsoon season, there may be an increase in the rainfall over India. The moisture which is being provided by the equatorial currents will come towards the Indian side and African side. Okay, so a hypothetical question can be made, that what will happen if, let's say, positive phase of the Indian Ocean dipole happens along with the La Nina event. Will it rain more in Africa? Then yes, it will rain more in Africa and it will feel warmer there. Okay, flooding events can take place there. So here we see the Indian Ocean dipole again. Very, very simple and very important factor for us, that it will have heavy rains in the the African side. This is the Indian side which is coming in between. Okay, so if it going like this, if it is flowing like this clockwise, then it is the positive phase of the Indian Ocean dipole. All right, and if it's like going like this, then it is the negative phase of the Indian Ocean dipole. Okay, here it is written also, the positive and negative phase. So very, very simple for us to understand. Now let us talk about the distribution of the Indian rainfall. So here you can see a map of the forecast. What we are seeing, that there are three categories here: below normal. Sorry, just a second, I'll change the pan color. Okay, so below normal, normal, and above normal. It may not be very visible to you. All right, so what we are seeing here, that most of the India will be receiving above normal rainfall, specifically this portion. So Bay of Bengal portion, we can see here. All right, in the Arabian Sea portion, we can see above normal rainfall here. Okay, in this portion. And this is the rain shadow portion. So we can see below normal rainfall here in this series and this portion, and here in the central plateaus. Okay. All right. So what we see here, that India receives 70 to 90% of its annual rainfall in 4 months of June to September. That means southwest monsoon is the major water delivering event in India, or rain delivering event in India. And a normal and well distributed monsoon is crucial for 61% of the Indian farmers. That means 61% of the Indian farmers are still completely dependent on rain-fed irrigation, who are dependent on rain for practicing agriculture. And the monsoon has a direct impact on Indian economy as well. Okay, so what is the economic impact? What is the economic impact? All right, so uniform distribution leads to a successful monsoon season. Uniform distribution means that overall, if we are seeing 92 centimeter of rain in India between these 4 months, so what we would like that every bit and corner of India gets some sort of equal rainfall. So there is no extreme event such as either flooding or drying, let's say, or droughts. All right, so we do not want to see these both extreme events. We want the graph to be like this. Okay, we don't want it with double peak like this. All right, so we want a equitable distribution of the rainfall. So uniform distribution leads to a successful monsoon season, which boosts farm production and income of both farmers and laborers. So if we are seeing that the primary productivity is increasing, then of course the secondary productivity will increase, the secondary market will increase. All right, the laborers' income will increase, the transportation facilities will increase, they will have some more income. So this has an impact on the rural household income, which then stimulates demand for goods and services, especially the rural demand. Okay, because if they have money, they will be having more demand, and with appropriate supply, we can see an economic growth. Okay, so monsoon has a direct relation with the Indian economy. And what sort of monsoon? An equally distributed monsoon. Okay, if the monsoon distribution is like this, okay, if there is somewhere there are droughts, somewhere there are floods, then it will have a negative impact, in fact. Okay, like this. So we don't want this. All right. Next, what we see that we can just have a review of the overall lecture, especially the El Nino La Nina part. So what we see here, I'll divide it into three portions. Let's say this is India, this is Australia, this is the Southern Americas, all right, and this is the African subcontinent. So what we are seeing here, normal trade winds. Okay, normal trade winds are blowing this side. The warm currents are coming this side. Okay, moisture is coming this side. So raining is this side in Australia. Okay. And what happens during the La Nina time? This gets stronger, the La Nina time. And in El Nino time, what happens? This gets weaker. Okay, so this floods here. In the La Nina time, here is upwelling. Okay, this side is good upwelling, and here it is flooding. Okay, in the Australian side and the Indonesian, Malaysian side. Okay, next what we see, we want it to rain in India. So we want a positive IOD. We want a positive IOD. So positive IOD is like this. Okay, the further carrying of the moisture from here to the African side. So when there is a positive IOD, what will happen? Here heating will happen as well as good rains will happen in the African side. Okay, in negative IOD, what will happen? That this movement will become weaker and it will flood the Australia more and more. Okay, so this is a complete, let's say, reiteration of the El Nino La Nina event and the IOD. All right, so this is the end of the lecture for today. I hope you enjoyed the lecture. You can leave your feedback in the comment section. Thank you very much for your presence. Have a great day. Study well. See you soon.